Yes, in the previous class, the one more technique, that is the flame photometry. And in that class, what is meant by flame photometry? Then what is the principle behind the flame photometry? That part is studied in the previous class. You know, a liquid sample that containing radicals or the elements, the solution of those elements or the radicals is allowed to comes in contact with the flame. What happens here, when a solution is comes in contact with the flame, what happens, the solvent evaporates so that there is a residue of the compounds of the element is left. Then when the radiations are allowed to pass in the sample of the substance, what happens? It decomposes into atoms, and these atoms absorb the radiations, and what happens? They excite the atoms from the ground state to lower energy state to higher energy state, and after that, when they return back, they emit the radiations. And here, the intensity of the radiation that are emitted out, it gives the amount of the element that is present, and depending upon the wavelength, what is the wavelength as well the color, what is the element or a radical is present, that can be detected very easily. Now we go for the instrumentation, and the instrumentation picture is repainted on a board. See here, a flame photometry is composed of pressure regulator and flow meter. The second one is atomizer. Third one is a burner is there. Then mirrors are placed. Slit is there. Optical system and the photosensitive detector. Everything is repainted in the figure. Here the atomizer is there, monochromator, flame, amplifier. This is optical system where the photosensitive detector is placed. Let us study one by one. The first one is pressure regulator and flow meter. See here, these are used for the proper adjustment of the pressure as well as the flow of the gas. Here, fuel is placed here. At the same time, oxidants are added. The fuel as well as the oxidants are enters in the atomizer, and with a specific rate they start to flow upwards. Clear? The rate of the fuel as well as the oxidant, they are in the form of gases. They are inserted in the photometer, and the flow rate is of 2 to 10 feet per hour. Means they can flow in the atomizer. Here the flow rate is 2 to, that is 10 feet. The solution moves upwards for a per hour, and this is the best adjustment of the pressure regulator and the flow meter. The second one is atomizer is there, analyzer is placed. Analyzer means a beaker containing a solution of the elements or the radicals or a compound of the element is placed here. The substance is dissolved in a particular solvent. That solution is taken in the beaker. Then in the atomizer, these are used to introduce the liquid sample to the flame. Here the liquid sample flows upwards. At the same time, the oxidant as well as the fuel is also moving upwards. What happens here? the fuel catches fire in presence of oxidant, and here combustion starts, combustion of the fuel starts, which gives the a flame. At the same time, in the atomizer, the analyzer is placed. That analyzer in the form of liquid, that liquid is also starts to flow upwards. Then it comes in contact with the flame with a stable and reproducible rate. They are classified as those which introduced the spray into the condensing chamber for removing the larger droplets. What is to be done here? The solution that is present, it is allowed to spray. When it is allowed to spray, the droplets are formed, and some of the droplets are having a bigger size. They can be replaced off so that we get the uniform and the reproducible sample droplets are to be obtained, and those droplets are comes in contact with the flame, and that is called as atomizer. And here 4 to 5 ml of the sample is allowed to spray. 4 to 5 ml of the sample, that is it is allowed to spray to the flame. But out of that, only 5% of the sample that reaches the flame. Clear? Means 4 to 5 ml of the sample is allowed to spray. The sample is in the form of small droplets. Bigger droplets are replaced off. Uniform droplets are comes in contact with the flame. But out of 5 to ml, only 5% of the droplets are comes in contact with that is a flame. Next one is, the third one is burner. Here the burner is used to have the flame with a proper process, and it functions. The first one is, the flame should possess the ability to evaporate the sample, because the sample is in the form of solution. When the droplets of the solutions are comes in contact with the flame, what happens? The flame should have a capacity of evaporating the solvent, so that there is a residual sample is left. Therefore, the first one is, the flame should possess the ability to evaporate the liquid droplets from the solution, and there is a resulting in the formation of solid, that is residue. Second one is, the flame should decompose the solid residue. Means here the liquid drops are there, and these liquid drops are converted in the form of solid residue. And this solid residue that is obtained, it decomposes. Here the decomposition takes place, and on decomposition we get the atoms of the different, that is atoms of the different elements that are present in the solution. The third one is, the flame must have a capacity of excitation. Means whatever the atoms are obtained, here atoms are obtained, these atoms take the heat energy from the flame, and what happens? The excitation takes place. The excitation means the atoms are moved towards the higher energy state. They start to move. That is the capacity of the flame. Means first flame, when droplets are comes in contact with the flame, evaporation takes place, solid residue is obtained, that solid residue decomposes into free atoms. These atoms absorb the heat energy, and the excitation takes place. And here the burners are composed with the oxyacetylene flame or oxyhydrogen flame. Oxyacetylene flame produces the 3273 Kelvin of the heat. At the same time, the oxyhydrogen produces the 2973 Kelvin of the heat energy. Then what happens when there is a excitation takes place? Then there is a concave mirror is placed. The radiations from the means the radiations are completely spread in all directions. When the atoms of the element absorb the energy, heat energy, and excitation takes place, and during the excitation, when they return back, they radiate the energy, and that energy is completely, that radiations are completely spread. Then what is the work of the mirror? The radiations from the flame is emitted in all directions in the space, and the mirror portion of the excited radiations will not reach at the detector. Means when the radiations are allowed to completely spread out, what happens? The radiations cannot reach the detector or optical system. Therefore, what is to be done? The mirror is placed. In order to increase the amount of the radiation reaching at the detector, a concave mirror is placed. When the concave mirror is placed just behind the, that is a monochromator. Here monochromator is there, flame is there, just behind the concave mirror is placed. The mirror is placed in such a way that the focal point of the mirror lies in between the entrance and the entrance of the monochromator. Means this is the radiations are, that is concentrated here, that is called as the focal point, and here the focal point of the mirror is at the entrance of the monochromator. Then when they pass it through the monochromator, here there is a slit is placed. The entrance of the slit is kept behind the monochromator. This is slit is there, variable slits are placed, and here the monochromator is placed. At the entrance of the monochromator, the slit is placed. The slit permits the radiations from the, that is a flame. Means whatever the radiations are coming here, they are filtered off, and here we get a selected entry of the optical system from the, that is exit slit, and allow the selected wavelength range from the radiations, and they are traveling towards the amplifier and towards the detector. Then this is called as a optical system. The optical system functions as the collector and monochromator of the light, and the focuses on the photosensitive detector. Here photosensitive detector take the radiations, and it gives the electrical signals, and due to the electrical signals from the radiations falling on them, the flame photometer that restricts the bandwidth as well as the radiant energy reaching the phototube. The amplifier in it to make the output read out the system available, including charts, records, and the digital display to have the proper data of the experiment. This is the simple experiment to detect the elements that are present in the given solution from the flame photometric technique. Okay, this is the instrumentation. I have not written here the notes, only what are the parts and what is the work of those parts explained. And for the notes, I will give in the form of PDF. Okay, thank you for your patience hearing.